Hello students, welcome to today's class. Today we will be seeing physical and chemical equilibrium question part 2. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. In this session, we will be practicing questions from 9 to 16. Question says that for the given reaction in gaseous phase, CO gaseous plus half O2 gaseous giving us CO2 gaseous, what is the ratio of Kc is to Kp? Options are A, RT raised to the power 1 by 2, B, RT raised to the power minus 1 by 2, C, RT raised to the power 1, and D, RT raised to the power minus 1. Your time to solve this question starts now. Your time is up. So in this question, basically, you are given a gaseous phase reaction in which carbon dioxide is being formed by the oxidation of carbon monoxide. The equation is already balanced. You don't need to balance it. Now you have to say that what is the ratio of Kc is to Kp. So the correct answer is A, RT raised to the power 1 by 2. We know the relation between equilibrium constant for pressure and concentration, and it is as Kp is equals to Kc RT raised to the power delta Ng. Now how we can calculate delta Ng? So delta Ng is basically the change in gaseous number of moles. So we know it very well that all the participants in this reaction are gases, right? So on the right hand side we have 1 mole of carbon dioxide, on the left hand side we have 1 mole of carbon monoxide and half mole of O2. So that will make us 1 mole of carbon dioxide minus 1 mole of minus 1.5 mole of reactants. Clear? So our answer will be minus 0.5. Clear? So we can put this thing back in the first equation. Kp is equals to Kc RT raised to the power 1 by 2 minus 1 by 2. So we have taken 0.5 as 1 by 2. Or else we can write that the ratio of Kc is to Kp is RT raised to the power 1 by 2 or root under RT. Clear? So the correct answer is A, RT raised to the power 1 by 2. Next question, for the reaction SO2 reacting with half O2 gaseous giving us SO3 gaseous. If Kp is equals to Kc RT raised to the power x, where the symbol have their usual meanings, then the value of x is, assuming ideality, options are A minus 1, B minus 1 by 2, C 1 by 2 and D 1. So your time to solve this question starts now. Your time is up. In this question, we have been given an equation where our sulfur dioxide is being oxidized to sulfur trioxide and this equation is already balanced. Now we have to determine the relation between Kp and Kc such that we can get the value of x. So your correct answer will be B, which is minus 1 by 2. If you write the change in Gaussian number of moles, it is number of reactants on the right side. It's subtracted from the number of product, where these are number of moles of gaseous elements, right? So that should be kept in mind. So NP is number of moles of products, or you can say specifically number of moles of gaseous products minus NR, which is number of moles of gaseous reactants. So that will be calculated as delta Ng. So delta Ng is here what? Delta Ng is here 1 minus 1.5. Here it is 1, and for this it is 1 plus 1 by 2, which is 1.5. So delta Ng comes out to be minus 1 by 2. So x value is minus 1 by 2. Next question, the ratio of Kp is to Kc for the reaction. CO plus half O2 gaseous is giving us CO2 gaseous is, options are A 1 by root under RT, B RT raised to the power half, C RT, and D 1. So you are given the oxidation of carbon monoxide to carbon dioxide and you have to find the ratio between Kp to Kc. Your correct answer is A 1 by root under RT. We know that Kp is equals to Kc RT delta Ng. Now for the given equation, the delta Ng comes out to be minus 1 by 2. Or we can write this delta Ng value as minus 1 by 2 in the equation here. So Kp is equals to Kc RT raised to the power 1 by 2 minus 1 by 2. Or else we can write Kp is equals to Kc by root under RT, or Kp by Kc is equals to 1 by root under RT as your answer. Next question, a reversible chemical reaction is having two reactants in equilibrium if the concentration of the reactants are doubled and the equilibrium constant will be, options are A B doubled, B become 1/4, C B halved, and D remain the same. So you have 10 seconds to solve this question. Your time starts now. Your time is up. So you have to say that you are given a reversible chemical reaction which is having two reactants. Now it is said that you are doubling the concentration of each of these reactants, then what will be the effect on equilibrium constant, that is K? Correct answer is D, it will remain same. So our equilibrium constant represented by K, it depends only on the temperature, right? You can change the amount of product and reactant, but their ratio will be remaining same, right? So upon changing the temperature, we can only change the equilibrium constant and not upon changing the concentration. So therefore, doubling the concentration will have no effect on the equilibrium constant and it will be same. Next question, consider the equilibrium reactions. H3PO4 is going to H plus and H2PO4 minus with the equilibrium constant as K1. H2PO4 minus is further dissociating to H plus and HPO42 minus with K2 equilibrium constant, and this HPO42 minus is dissociating to H plus and PO43 minus where the equilibrium constant is K3. Now what we have to do is we have to know the equilibrium constant K for this H3PO4 dissociation to 3 moles of H plus and 1 mole of PO43 minus. Your options are A K1 by K2 multiplied by K3, B K1 K2 K3 all three are mutually multiplied, C K2 by K1 multiplied by K3, and D K1 plus K2 plus K3. So your time to solve this question starts now. Your time is up. So basically in this reaction we are given the multi-stage dissociation of this H3PO4 acid through 3 steps, as there are 3 ionizable H plus. Okay, and for each of these steps we are given the K1, K2 and K3 which are the equilibrium constant, right? Now using these 3 equations you have to form these equation which is the ultimate equation, and accordingly you have to adjust the equilibrium constant, right? So the correct answer will be K will be here K1 multiplied by K2 multiplied by K3. So if we write for the first equation, what will be K1? K1 will be the concentration of H plus H2PO4 minus, which is our product, divided by H3PO4. So this is equation 1. For the second equilibrium constant, we will write this thing as H2PO4 minus going to H plus and HPO4 2 minus. Here it is K2. Okay. And here we can write K2 as H plus HPO42 minus by H2PO4 minus as equation 2. And in equation 3, we will write HPO42 minus where the equilibrium constant is K3, is going to H plus PO4 3 minus. Again, we can write K3 here as the concentration of reactants, which is here, divided by the concentration of products. Now, if you add these three equations, we will get the ultimate equation which we are searching for. Now, while adding the equation, what will happen to the equilibrium constant? The equilibrium constant will be multiplied. So, whenever we add the equation, the equilibrium constant gets multiplied. When we subtract them, the equilibrium constant gets divided. Next question. If K1 and K2 are the equilibrium constant for the equilibria 1 and 2 respectively, what is the relationship between the two constants? First is oxidation of sulfur dioxide to sulfur trioxide. Equilibrium constant is K1. Second is your SO3 going to SO2 and O2. Means the reverse reaction, but with a different stoichiometric coefficient and again with a different equilibrium constant. Now you have to determine that what is the relation between these two. If K1 options are K1 square is equals to 1 by K2, B K2 is equals to K1 square, C K1 is equals to 1 by K2, and D K1 is equals to K2. So your time to solve this question starts now. Your time is up. So what is the question? Question is saying that suppose these are the two equations, only the difference between these two equations is that the second equation is the reverse and the 2 multiplied thing. Okay, so you reverse this equation, multiply the equation by 2, you will get the second equation. This is the only difference between the equation. So it is asking that when we will do such things, what will happen to the equilibrium constant? Correct answer is A, K1 square is equals to 1 by K2. Now reaction 2 is what? Is double and reverse of 1, as I have said you. So what we will do? Whenever we reverse the reaction, the equilibrium constant also is the reciprocal of the initial one, and when we double it or triple it, the same power goes to the equilibrium constant. So when we are reversing, it is 1 by K1, and then we are multiplying it by 2, so we do the square terms. Okay, so 1 square is already 1 and K1 square, so that gives us K1 square is equals to 1 by K2, which is our correct answer, A. Next question. For the following three reactions 1, 2 and 3, the equilibrium constant are given. For first it is CO gaseous plus H2O giving us CO2 plus H2K1, CH4 plus H2O, CO gaseous plus 3H2, 3 is CH4 plus 2H2 giving us CO2 plus 4H2, K3. Which of the following relation is correct? A is K3 is equals to K1 into K2, B is K3 into K2 cube is equals to K1 square, C is K1 root under K2 is equals to K3, D is K2 K3 is equals to K1. So your time to solve this question starts now. Your time is up. So what we are given is we are given three equations. First is what? First is simply hydrolysis of carbon monoxide, which is giving us CO2. Second is what? Second is hydrolysis of methane. And third is again hydrolysis of methane, but with a different stoichiometric coefficient. So what we have to do is we have to find the relation between these three. Clear? Okay. So the relation is K3 is equals to K1 into K2. If we write CO plus H2O giving us CO2 plus H2, then what will be K1 here accordingly? So it will be concentration of reactants divided by concentration of products. This is equation 1. For equation 2, we will write K2 as concentration of CO multiplied by concentration of H2 whole cube, because there is 3 as the stoichiometric coefficient, then concentration of methane and concentration of water. So this is our K2, and we write it as equation number 2. If we add equation 1 and 2, what we will get? We will get this equation, and simultaneously your K3 will be what? K1 into K2. When you add the equation, equilibrium constant gets multiplied, right? You can see it very clearly. So we can write from here that K3 is equals to K1 into K2, because this is nothing but our K3. Clear? You got it? Okay. Next question, the equilibrium constant Kc for the reaction, which is sulfur trioxide going to sulfur dioxide and half oxygen gaseous, is 4.9 into 10 to the power minus 2. The value of Kc for the reaction, which is this reaction, will be approximately equal to A 416, B 2.40 into 10 to the power minus 3, C 9.8 into 10 to the power minus 2, and D 4.9 into 10 to the power minus 2. So your time to solve this question starts now. Your time is up. So you are given two reactions, and both reactions are almost same. Only the difference is that the second equation is just multiplied by 2. So we got this thing, and it is also reversed at the same time. Now for the first reaction, Kc value is given. Using this value, you have to find the Kc value for the next reaction. So correct answer will be A 416. If we write the equilibrium constant for the given reaction, for this reaction, how we will write it? It will be Kc is equals to 1 by 4.9 into 10 to the power minus 2. How I have written it? So the first equation whose equilibrium constant is given, we have just reversed the equation to get the second equation, right? So on reversing it, the equilibrium constant gets reciprocated, right? So we get this thing, okay? Now in the further part, we have multiplied it by 2. So what will happen to now the equilibrium constant? It will also get square. So that will be 10 to the power 4 on the upside, right? Because this 10 to the power minus 2 is gone upward, divide by 4.9 whole square, that will give you 416.493, or approximately we can write it as 416. So this is your Kc for the new reaction. So this was the answer of your question. Thank you for attending this session. Okay.